Hello. This is going to cover Unit 2, so we'll talk a little bit about the assignments, and I'm also going to do some example coding. If you have any questions on the topics, you can post in the Unit 2 discussion board. But for now, what are we doing? Well, we are going to be working with just really basic Python code to start with. We are going to create variables, work with assignment statements, do printing to the screen, and getting input from the keyboard. So, you'll cover these concept introductions here. There is a link to the textbook, and then we have an exercise. So the exercise is the, practicing with the actual coding part. The exercise will go through how to kind of set up the REPL folders, but basically with program 1, you'll access some starter code here. Just a moment. So when you click on the starter code, it will bring you to a screen like this. This will load. There's some starter code. And then you'll click on Fork REPL. That will create a copy of this, but under your name, so you can make changes to it. And currently, it just asks what is your name and then displays the name to the screen. You're going to make some modifications just using the existing code as reference, so that instead of just the name, you'll also ask what the year is, what the course is, and then you'll display a little information at the end. So instead of just hello, name, you'll have welcome to semester, year, looking forward to having you in course name, and so on. So most of these kind of go through that. The starter code here starts with 2 numbers and gets the sum. You'll add in a third number. For this one, it is a receipt for an item, so you'll kind of work on this one on your own. But again, if you need some brainstorming time or just some ideas or hints, post in the discussion board. But basically, this one, it should ask what the name of one item is, and then that item's price, what the name of a second item is, and that item's price, what's the tax rate, and then calculate the entire receipt, what gets shown. How much the burrito is, how much the I spelled quesadilla wrong, but whatever. How much the quesadilla is, the subtotal, plus the tax, and then the final total. So those will be there, and again, post in the discussion board if you're having kind of like a roadblock, if you're not sure where to begin, or if you get stuck on something while you're working on it. And then the data representation is not code related, it's just more about how computers store data, like what is text, letters, images, videos. How does a computer actually store this information if it's all binary? Okay, so I'm still working on this page, but for the introduction for the week, you'll find more information here. I have this for your notes part, where if you're keeping notes, which you should have your own personal notes. These are the items that you need to be able to answer to show that you know the topic. So we'll also go through these as I do some example coding. And with the Python for Everybody book, this also goes over the same topics that we're going over. Now, I do want to bring up that these commands, all of the example code in this book is using it from the console and not actually writing a program, at least on this chapter. So for instance, if I do this and I add print, this is a program, and I hit run, this is a program, that's the program, it ran. Yes, so, but if I come over here and I just start typing something, I say print A, then it will give me that information. So technically, Python is running over here already, and this is what these commands are. When you see these arrows, that's just a prompt command where you're kind of directly interfacing with Python, but you're not writing a program. So it's just doing that to kind of show you different parts of Python without getting into a really big program. So for instance, if we do the type 3.2, that's over here, that'll tell us class is a float. So a float is a number that has a decimal value or a fractional bit. If we have a whole number, it can be positive, negative, Oops, I did that wrong. It can be whatever. It'll be an integer. So whole numbers are integers. Numbers with decimal parts are floats. Any text that we put in double quotes, so let's say type of hello, that's a string. It can also be in single quotes. I'm just used to using double quotes because in C and C, single quotes and double quotes mean different things. So I'll pretty much always be using double quotes, but over here they're using single quotes. In Python, you can mix between them. Once you get into C# or Java or C++, single quote, double quote have different meanings, but they're interchangeable for now. Okay, so starting off, we have our variables. Variables are what we need to actually store data in a program. We could make a program that just kind of displays information, like the year is 2022, it is June 7th, at least today it is, and you can run it, but if I wanted this to always be up to date, it wouldn't make sense for me to come back in here and like every day update the code like that. That just wouldn't make any sense. I'm printing data, but this is all hard-coded data. If we want variables, we can then replace these numbers with our variables instead and have a program that updates based on user input or today's day or other things like that. So let's say this program starts with just saying, what's a good example? We'll stay on that page. Oops. Let's say we're writing a program that's going to format a name. So my name is Rachel Singh, but if it were printed in like a document or something, it might say Singh, comma, Rachel. So that's that part. What if I want it in either order, Rachel Singh or Singh Rachel? Well, it would be good to perhaps store those in variables. So I'm going to create two string variables. And so I'll do, let's say, first name is Rachel. Last name is Singh. And of course, not everyone just has two names. I have 4 names. People have all sorts of numbers of names, but this is just a small example. So I have the variable first name. I'm using the assignment operator, which is this equal sign. And then I have a value here on the right-hand side. So variable name that I've created should probably actually be named like that if I want to use proper Python naming. Again, I come from C++, so I have a certain way that I like to do things. But we have first name and last name. Now I can print out first name. I can print out last name. So I'm going to comment those out real quick. These will just end up showing on different lines, but I could add a comma, last name, and that will show up like this. It automatically adds a space when you put a comma in between. So let's add some code to show that this is what this is going to be. So this is writing with print first name, comma, last name. I'll do just print with empty. I think I could just do this to do a new line. Yeah. Let's try print first name plus last name. So it's not going to do math because these are strings. Strings have their own special way that they work. But if we do first name plus last name, it does not put that space in there. It just puts right next to each other, side by side. But we could also rearrange these. We could have last name, first name, and so on. So this is kind of the way we want it for just our normal first name, last name. Let's also do it for last name, first name, but with a comma. So I'll erase this for now. We'll want to display the last name as the first item. I want a comma between them, so I'll use the plus sign and then I add this, a string literal. I'll do first name, and we'll just copy this here so we can see. This is just a label to say, hey, this is the kind of print we are doing. So here we have kind of the normal formatting. Here's more of like a data formatting, if it was on a form or something. And then this one is not really a useful formatting, but maybe if we were generating student emails based on names, that would be useful. So again, we have variables. This one's just a simple string. We're assigning it a string value. We use the equal sign, which is known as the assignment operator, to set this variable equal to that. So on the left-hand side is where the variable goes. The right-hand side is where the data or the value goes. And we can print out the data inside of double quotes. Or if we want to display a variable's value, then we use the variable name itself. Now, a few other things. Let's say I had, let's say we're doing Mario, and, you know, in the very, very old Super Mario Brothers movie, they said his last name was also Mario. So we can say last name is equal to first name instead of doing this. So then we can set first name to Mario. We can set last name to whatever first name is, and that gives us a last name of Mario as well. Mario. So we can use a variable on the right-hand side of our assignment operator, and that will copy whatever's inside of this variable to this variable. So then they have the same value. Sometimes useful, sometimes not. Usually we do this more for like math operations. So those are some really basic strings. We can also work with integers and floats. Let me just move that over there for now. How does Python know what kind of data we're storing? Well, it's from the assignment operator. So we can change this up. Let's say, let's have a book title. Let's see if I have a book down here. And we can have a, I guess I wouldn't really store the ISBN number as a integer. I would store that as a string. Let's just say this is a bookstore, and we're going to store the quantity of this book that is in stock. Book in stock. Let's say we have 5 copies in stock. And say book price. I don't know what the price is, but let's just make up something. So here, this one is a float. This one is an integer. And this one is a string. Now, if I run this, nothing's going to happen because we have no print statements. It creates the variables, but then the program ends. So we can also print these out. We can say book title, book in stock, book price. We'll run that, and it just gives us the data. Now, from a design standpoint, this isn't really good for a user who just comes in fresh and is using this program. They'll be like, discrete mathematics 5, 123, 45, what does that mean? So it's good to have labels along with this. So for instance, I can put in title, and I'll put a comma in between. That will give us title as a label, and then discrete math. We can put books in stock, or maybe that's kind of long. Maybe we'd just do in stock. Run. In stock is 5, and price, run, price 1, 2, 3, 4, 5. Now, if we want this to look like money, like in US dollars, we would need to actually convert it. I have this at the end of our exercise where we can print this kind of ugly thing, but that will let us format a price like a price. So we'll keep that one. We'll just do another version here. So we copy that and put it in there. So basically in here, this is saying we're going to have a $sign, and then this is kind of the format specification. We want commas. We want 2 numbers to the right of the decimal point. and then we use that to format book price. So then that one will show up like this. Or if we change this to $123.40, if we don't format it, that 0 is not going to show up. But if we do format it, that 0 will show up. Okay. Now let's say we want to also just display these, but not with the comma. We want to just do a plus sign at the end. Well, that will work for our strings. So technically we can actually do this, but it won't work if we're mixing between a string, like right here, and a integer or a float. It'll give us an error. So if we look at this error, we'll say main line 6. Line 6 is the problem. Can only concatenate string, not int, to string. So concatenating is when we're just putting these two strings together. We cannot concatenate an integer, because with integers, for plus sign, that would be math. But for strings, it's concatenating. So what we have to do is we have to convert this into a string. Same thing for the book price. So down here, if we're going to display book price like that, we need to surround it inside of the str text. That way, that changes it into a string. So then this still doesn't look super great. We could do this. So then there's some spacing. We can also use the tab character, which is \T, I believe. I believe that is a backslash. But that will let us add some tabbing, and then they'll kind of align based on that. So I don't know if you can tell. Let me get rid of tabbing on this one, and you can see that the other ones have been tabbed and then align that way. If we wanted new lines, we could do /in, and that will tell us to go to a new line before displaying the next thing. So title, new line, book title. Title, new line, and then the book title. So those can also be useful for formatting. Yeah. Okay. Let's say we want the user to enter in how much the stock is and what the price is. So in this case, we would need to have an input statement. For book title, let's just do this. Erase that part. We're going to use the input function. And then inside the input function, we display text that we're going to display to the screen. So basically, what do we want to show the user to say this is what we're looking for? We'll say, please enter book title. So when I run this could be anything. I don't really have any other books around here, but let's just say calculus. And then that updates here. Whatever gets entered from the keyboard, that gets stored in our book title. And then anytime we use book title, it will be displayed to the screen. Books in stock. Books in stock should be an integer, so we actually have to do something a little different. We're going to have to change it to an int. So similar to how we change it to a string down here, when we get the input's going to be a string every time, but we need it to be an integer, because what if we need to do math with it, like add 1 to the stock? So we can do int input, please enter number in stock. And we can run that. And those will get updated. And let's do price. So in this case, this will be float input, please enter the price. Now let's put a little $sign there so they know. Oh, and we don't need that part. Go ahead and run. And so then the variables get updated down here as well. So after that, I'll go ahead and erase that part. Let's just say we sold 2 books. So 2 books have been sold. That's just to let the user using the program know what's going on. And I'm going to take the book in stock, and I'm going to set it equal to whatever it was before minus 2, because 2 books were sold. So after that happens, we'll just add some extra prints here to kind of separate out the sections. We'll print the same data again. So calc 5. So 2 books haven't been sold. So we had 5 in stock, and now we have 3 in stock. Oops, I'm going to do another print here just to make it easier to read. Okay, we can also do the same math operation in less code by using the minus equal decrement operator. So this will do the exact same thing. So 3, 2, 1. Let's say we also want to set a sale. Well, we want a print. Let's go ahead and say sale is equal to input. How many dollars on sale? We're not going to get into percents right now. We're not going to overcomplicate it. And this needs to be in a float so we can actually do math with it. So after we enter the sale amount, we'll do book price minus equals the sale. Or if we did it the long way, this would look like book price is equal to whatever the current book price is minus the sale. So let's go ahead and run this. Book title, we have 5 in stock and they're $100. On sale, we're going to take $25 off. 2 books got sold, so then now we can see its price is $75. The in-stock amount is 3. So just doing basic math operations, we can also do multiplication, we can do division, we can do addition, and so on. So let's boil down the math into its own really simple program real quick, just so we can see all the operators. So I'm going to just call this math program, and we'll have a couple numbers. So we'll say number 1 is equal to, we can do input, enter the first number. However, this again needs to be something we can calculate. By default, this is a string, so we need to change it to a float by putting it inside of the float function here. And we can do the same for number 2. And then we can do operations on it. So the sum of the two numbers is number 1 plus number 2. The difference is number 1 minus number 2. The product is number 1 times number 2. And the quotient is number 1 divided by number 2. And then at the end we can print out the data. So sum, and we can output sum. Just output each of these like that. I have like an ant on me. Summertime sucks. Ants everywhere. Difference, product, quotient. Okay. So when we run this, it'll say math program, it'll ask us to enter 2 numbers, and then we'll do a bunch of math with those and display the results. So run. Let's say we'll do 6 and 3. I should have added a little print here as well. I like my programs to be very readable. So as a side note, you'll notice that I tend to put things that are related into a chunk together, and then I have vertical spacing, and then another chunk of things that are related, and then vertical spacing, and then another chunk of things. I'd like to do the same with my programs so that the output is also similar. Chunks of things squished together, and then we'll see that it makes it easier to read. So you should also try to make your programs easy to read. Okay. So the result of 6 plus 3 is 9. 6 minus 3 is 3. 6 times 3 is 18. And 6 divided by 3 is 2. So this is a program using these. If we were looking at the textbook, it also talks about expressions. The expression is the math part without the equal sign, basically. So if we just type like 2 plus 2, that's an expression, and it gives us a result of 4 if we're typing in this Python console. We could also say x is 5, 5 plus 1 is 6, x plus 1 is also 6, and so on. You can kind of just type in a lot of test code in the console, And then while you're working on your program, you can say, okay, is this the right thing? Do I want number 1 times number 2? Except, yeah, it already still stored it from when I last ran the program. Now, the order of operations, the division and multiplication will happen first, then the sum and difference, but also you can use parentheses to specify the exact order you want things to run. For the most part, our math operations will just be simple formulas that'll give you like how to calculate the area of a rectangle. We can go into this more later on. We don't really need to worry about the modulus operator right this minute. It just gives us the remainder of a division versus the actual quotient. So you'll learn a lot more of that as you get deeper into computer science. And then the string operations we can concatenate, which we talked about, getting input. And again, if we do something like name is input, enter name, if we do this just straight in the console, it'll immediately execute that. And then I can say print name, and there we go. So it's a good place to kind of test things out to see if you're typing it out right, if you got the right syntax before putting in the program. And we talked about comments a little bit. Comments are just for humans to read. The computer ignores comments. We could say like math program by Rachel, June 7th, 2022. Those, I don't really require them per se. If it makes what is happening in your code clearer, that's good. But for instance, I don't need to put this. Add number 1 and number 2 together. I can see that happening from the code, so having the comment is kind of redundant, so that's not needed. Any information that's like, oh, I need to reference this later, or this might not be obvious what it's doing, so I'll add a note here. That's what comments are for. Okay. This also talks about variable names, and our variable names should be descriptive. A long time ago, our variable names were usually single letters, but we had limited space, limited screen space as well as memory, and we needed to use that efficiently. We can waste a little tiny bit of space using descriptive variable names. That is going to be good because it'll help you in the long run figuring out what is what and what is everything doing. So make sure you use descriptive names. And then as far as the debugging, this also gives you some tips, but make sure when it tells you what line there's an error on, that you look at the line first and foremost. So if I run this, I see invalid syntax on line 12. It tries to point out where it thinks the problem is, and it's pointing at number 2 right here, but in the language, it doesn't make sense to have variable. That doesn't do anything. But we could have variable divided by variable, and then that would be okay. And then there's also a list of glossary terms here that you can reference. Those are also important. And you can also do these extra examples if you want to, but we can also look at some of these. So that's pretty much it for this week. I'll have links to these 2 example programs in Canvas on the week introduction page, so you'll be able to find it there. And if you have any questions, feel free to post in the Unit 2 help, and I'll answer as soon as I see it. So